is visible.
Okay, thank you. So today I am going to discuss about the disruptive technologies for societal benefits. Before going to the main topic, just I want to mention that today this term is very common. What is this disruptive technology? So basically, this is the term Clayton M. Christensen, this is the professor at Harvard Business School, invented the term disruptive technology. Actually, this is very common to all of us, but this term is specifically invented by him. So what is this exactly? Basically, this is the technology that affects normal operation of a market or an industry. It displaces a well-established product or technology, creating a new industry or market. Now, new technology can either be sustaining or disruptive. While sustaining technology depends on incremental improvements in already existing technology, disruptive technology is a completely new one. So you can take the example, we are very familiar with this type of technologies, that artificial intelligence, 3D printing, virtual or augmented reality, next generation genomics, autonomous and near autonomous vehicles, advanced robotics, cloud technology, Internet of Things, automation of knowledge work, global internet penetration, renewable energy, advanced oil and gas exploration and recovery. So different types of technologies, these technologies are known as disruptive technologies. This changes the overall concept, overall market. We can also consider big data analytics, geo-tagging and GIS, cloud computing and everything as a service, robotic process automation. Already I mentioned 3D printing, again blockchain, drones are very common, unmanned aerial system, remote sensors and IoT. And these are basically how this technology can be incorporated, that based on some criteria that depends on high income countries, middle income countries, low income countries, because in which way the Western country will implement these technologies, that way we cannot implement or incorporate. So these are the few things that you need to consider. So technology impacts are there, but how it can be incorporated, that depends on several rules, several policies. Based on this, it has been divided into 3 levels. So what are the levels of these disruptive technologies? That is, first is LIC or FCP, that is low income, fragility or conflict and violence countries. Next level is middle income countries. Third level is high income countries, mainly for the Western countries like USA. So basically, based on this type of consideration, we can think about our designing, our innovation. And this is related to the Industry 4.0. And these are the technological pillars of this Industry 4.0. That's why the requirement for the disruptive technologies and the requirement for Industry 4.0 has been merged. So here also we require this cognitive computing, cybersecurity, cloud computing, mobile technologies, machine-to-machine interaction, 3D printing, advanced robotics, big data analytics, Internet of Things, RFID. So these are the things we need to consider. Now our objective is, if we develop the technology need to do something good for the society. Now people may have the idea that if we advance more in that technology, in that case, our environment may be affected. But if we can consider the technology in such a way so that it can sustain the environment, that is the major issue we need to consider. That's why right now there is a concept of Society 4.0, and nowadays it is redirected towards the Society 5.0. So there is a comparative analysis between the Society 4.0 and Society 5.0. If we consider Society 4.0 from the perspective of economies of scale, this is liberation from focus on efficiency. Whereas Society 5.0 tries to focus on problem solving and value creation. So a society where value is created. Next term is uniformity, that is from the Society 4.0, liberation from suppression of individuality. Now if we consider Society 5.0, this becomes diversity, a society where anyone can exercise diverse abilities. Next, if we can consider concentration. So society 4.0 consider liberation from disparity, whereas society 5.0 consider decentralization. So a society where anyone can get opportunities anytime from anywhere. That is the concept of IoT. Vulnerability is another factor. So in society 4.0, this is liberation from anxiety. Now society 5.0, it becomes resilience, a society where people can live and pursue challenges in security. And next, in high environmental impact, mass consumption of resources, in society 4.0, it becomes liberation from resources and environmental constraints. Here, society 5.0, it becomes sustainability and environmental harmony that I already mentioned, that we need to use this technology in such a way that we can provide some sustainable solution. A society where humankind lives in harmony with nature along with the advanced technologies. So there should be one the bridge between the technology industry 4.0 or disruptive technology and society 5.0, so that we can consider the societal benefits for this type of technologies. If we consider another thing for society 5.0, so this is our current society. AI will free humans from the burdensome work with analyzing huge amount of information. So if most of the information, most of the analyzing part, most of the things can be done by the AI tools. Number of AI tools are there. So AI logic are there, artificial intelligence we can apply, and accordingly it will reduce the load of our computation. And with an overflow of information, the work of finding and analyzing the information desired is difficult at a time. So this is the solution. Problem is this one, and solution can provide in society 5.0. This solution can be provided using disruptive technology. If we consider the problem, people do a large amount of work, their abilities had limitations, and the behavior of the physicality challenges constraint. So here the possibilities open to humans will expand through the use of robots, automatic driving cars, etc. So this is one facility in society 5.0. Next, here in this case, a variety of constraints exist with respect to social problems such as the aging society and regional depopulation, making a sufficient response difficult. So here social issues will be overcome and humans will be liberated from various types of constraints. And here problem is that knowledge and information are not shared and cross-sector value is difficult to create. But in the society 5.0, IoT will connect all people and things, all sorts of knowledge and information will be shared and totally new value will be born. So this is the relation between the disruptive technology and society 5.0. So there is a significant relation between disruptive technology, industry 4.0 and society 5.0. Also, you can see here in society 5.0, preventive examinations, robot-supported caregiving, plus extending healthy life expectancy, reducing the social cost. And you can see here energy diversification plus local production, stable supply of energy, greenhouse gas emission reduction, optimal value chain or automatic production by robot, plus promotion of sustainable industrializations or eliminate manual shortage. Here it is automating the agricultural industry or optimal home delivery, plus increasing production of foodstuffs or reducing waste. So these are all the features of the disruptive technology, which is possible in case of society 5.0. So you can see here that if we consider the societal benefits, we can consider this informatics is very important, and this is the infrastructure interoperability. What are the things we need to consider for the benefits? Ecosystem, biodiversity, agriculture, climate, energy, water, disasters, health, weather. So technology needs to do something for society. That is the major thing that we need to consider. So how well we can use our technology for society, and these are the main things we need to consider. So observation, experimental and model data, that is important for any application, any type of technology you need to do. Research products or traceability, measurement traceability, and informatics are already there. Tools, models, collaboration for transforming data into information, and we need to think about socio-ecological indicators. Finally, publications are there, assessments are there, educational resources are there, value-added data products are there. And from there, we can also do risk management that can be used for educational purpose, that can be used for climate adaptation, that can be used for vulnerability assessment, risk management. So these are the very few things that we can consider to analyze the impact of disruptive technology on society. So this is very common that one of the important technology in DT is the disruptive technology. So DT is actually a set of advanced technologies which can do something, which can change the definition of the society, which can transform the society 4.0 to society 5.0 like this. So this is, AI is the very common one. So we can consider the AI with this concept that it can do the predictive analytics that includes the deep learning, machine learning, natural language processing that includes classification, translation, data extraction, text to speech and speech to text are possible. Expert systems are there, number of expert systems are there. We can plan and optimize this thing using artificial intelligence. Robotics we can use, and obviously in case of COVID time, we can see that how much important these robotics are. What is the significance of robotics? Because in case of health assistance, healthcare nurse, they can do the work to transfer the medicines, to give the foods to the patients. So in this way, they can help a lot. So robotics helps a lot during this COVID time. Vision is obviously another important thing to recognize image, as well as machine visions are very much important. Now, this is the relation between AI, ML, NNDL, artificial intelligence, machine learning, neural network, and deep learning. So if we consider this one, artificial intelligence is the superset and machine learning is the subset. If we consider artificial intelligence, reproduction of human intellectual activities. Then machine learning is the subset, learning of rules and patterns hidden in data. And neural network is the subset of machine learning. So learning model that emulates brain activities. So basically modeling of neural signaling. And if we consider the artificial intelligence, number of component technologies are there, expert system, robotics, human interface, and many more. If we consider machine learning, obviously there is supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. So number of algorithms are there, and their classifications are also there. Next is deep learning. So learning using multi-layer neural network only. So it, with the application of deep learning, all the real life applications become very much easier, even including this medical science. Medical science improves a lot with this deep learning concept. So if we consider, given a bank customer's profile, should I sanction him or her a loan? This is the supervised learning. Given an audio track, separate the singer's voice from the background music, that is unsupervised learning. Automatically group your personal collection of photographs in Picasa into categories, that is unsupervised learning. Given a patient's X-ray image, diagnose if he has cancer, that is supervised learning. Now, if we consider the application of supervised learning, bioinformatics, cell phones are capable of learning biological information to authenticate user, providing security to system. Next is spam classification. Algorithm learns the different keywords that any spam messages generally contain, such as sales, or you are the lucky winner, etc. This is used in Gmail, where messages predicted as spam or malicious emails are preemptively filtered out. Object recognition for vision. The algorithm is trained with huge data set to identify objects. Face recognition. In applications like Facebook, systems takes photo, find faces, and identifies them using supervised algorithm. Now, application of unsupervised learning. Recommendation system. Netflix or YouTube recommends contents or products based on users' past purchase or their selections. So if you have already selected something or you have purchased something and these similar movies are there in the Netflix, they can suggest this thing based on your activities. They can suggest, they can recommend. Finding association rule discovers probability to find people who buy X also tends to buy Y. Anomaly detection, trained with a lot of normal instances so that it can detect whether it is anomaly or not. And this is the third one, reinforcement learning application areas. How to walk. Robot first tries one big step and falls. Outcome of a fall is a data point the reinforcement learning algorithm responds to. Since feedback is negative, algorithm adjusts action to try smaller steps. It can also be applied in healthcare industries such as for medication dosing, optimization of treatment policies for those suffering from chronic clinical trials, etc. Problems in real world. Test space may be very large, such environment cannot be fully discovered. Lot of agents interact with each other, and it can be solved using deep reinforcement algorithm. Application of deep learning, many applications are there. So this is, if we want to discuss on this, the separate discussions are required, but we can mention few of them here. Self-driving cars, they generally adapt to ever-changing traffic situation and get better and better at driving over a period of time. Speech recognition, all of us use several mobile apps today that are capable of recognizing our speech. Apple Siri, Amazon's Alexa, Microsoft Cortana, and Google's Assistants, all these use deep learning techniques. Mobile apps, we use several web-based and mobile apps for organizing our photos. Face detection, face ID, face tagging, identifying objects in an image, all these use deep learning. Now, if we consider AI during pandemic, we can divide it into 3 steps: detection, prevention, response, and recovery. If we consider detection, early warning, detection anomalies and digital smoke signals, as for example, blue dot. Diagnosis, pattern recognition using medical imagery and symptom data, as for example, CT scans. If we consider prevention, in that case, this is the prediction part, calculating a person's probability of infection. So there is tool that is EpiRisk. For surveillance, we can consider to monitor and track contagion in real time. So contact tracing, number of contact tracing apps are there to find out that how many times you have in contact with the infected persons. Information, personalized news and content moderation to fight misinformation via social network. So fake news detection is possible through this. Next is response. In this stage, delivery is one part. Drones for materials transport, robots for high exposure tasks at hospitals like cruiser robot. Service automation, deploying triaging virtual assistants and chatbots, as for example, Canada's COVID-19 chatbot, so who can help the service and who can guide the patients. And in the recovery phase, there is the monitoring, track economics recovery through satellite, GPS, and social media data. The tool is WeBank. Now, question is how DT can assess response to crisis. DT is the disruptive technologies. It can fight misinformation. It can provide virtual assistance and chatbot. It can identify, contact vulnerable high-risk individuals, accelerate training and education of healthcare personnel. Capabilities. It has the capabilities for pandemic prevention and control. It can rapidly detect, diagnose, and prevent spread of virus. It can identify virus transmission chains and monitor broader economic impact. AI-powered early warning systems help to detect disease pattern. Semi-autonomous robots and drones deployed to respond to immediate needs. Contact tracing systems can identify possible infection routes. So through which route the virus can come. So that can be easily detected through these contact tracing systems. In a fully automated environment, CCTV cameras become the most comfortable mode of deployment for image analytics, artificial intelligence, machine learning. Computer vision technology extends by integrating CCTV camera with AI and ML. Crowd monitoring and social distancing can be possible. Human body temperature monitoring can be possible. PPE violations such as masks not being used properly by the people in a crowd, that can be easily determined. Hotspot detections can be possible. Access control mechanisms integrated with attendance system is also the application of these disruptive technologies. Facial recognition solutions for quick and easy user control. This is another application areas of DT. Another important technology in DT is Internet of Things. Now, when you consider this Internet of Things, I just want to mention the 3 points here. That almost we can see that M2M, IoT, IoE are almost same. So what is the difference? Why not M2M? Why not IoT? Why not IoE? What is the requirement of considering these different terminologies? So if we consider M2M, M2M is machine-to-machine interaction. So a device that captures an event, transmits it over a network to an operation and translates it into meaningful information. That is M2M. So this is like the example, your alarm clock is attached with your coffee maker. So when your alarm clock will active, at that time, your coffee maker will also be active. So this signal from alarm will directly go to coffee maker so that coffee maker can be active. So this is machine-to-machine interaction. Normally this is unidirectional because there is no need of coffee maker to go to alarm. Alarm signal need to go to coffee maker to make it active. Now what is IoT then? So this is your intranet mainly. Within the local network it can be possible this type of interaction. So any type of machine-to-machine interaction can be, it may be either in your room or it can be possible outside, so that only the interaction between the devices. It does not check other issues. But if we consider IoT, Internet of Things, so a network of uniquely identifiable things that communicate without human interaction using IP connectivity. So when you want to switch off your AC, your home AC from your office, so in that case, you can take the help of app. Through this app, from your office, you can switch off AC of your room. So this is, you can say, this signal is example of Internet of Things. Here we need to take the help of the IP connectivity, but without human intervention. No human intervention is required here. Same thing also when you will come towards your home from your office. At that time, automatically, the sensor can sense this one, or you can press some button. Accordingly, your room's light, fan, all can switch on. So these are the examples of IoT. So this cannot take any decision, just do some things. So some number of things can be connected to each other and do some works. Then what is the requirement of thinking about IoE? So why IoT is not sufficient, we need to think about IoE. So IoE, if we consider IoT is the super subset, IoE is the superset, Internet of Everything. So it's bringing together the people, process, data, and things to make network connection more relevant by turning information into actions. So how is it possible? So if we consider that there is one IoE-based helmet and one biker wear this IoE-enabled helmet, and he made an accident, road accident. At the time, what happens? The sensors in this helmet can sense the event and also sense the type of the accident, what this can do. There are some decision capacities. So all the things are there, people, process, data, and things. So that's why they can do different things. First, they can check the nearest hospitals and whether these hospitals have the free beds. So accordingly, if the beds are available, they can provide the instruction about the incidents, as well as they can also give the notification to the ambulance, or also the hospital can provide the ambulance and also make the exact location of this accident spot. So accordingly, ambulance can come, and before reaching, patient can reach to the hospital, doctors can arrange everything so that when patient will go there, immediately the treatment can be possible. Now, at the same time, when they took this patient to the ambulance, they can provide the facilities. This helmet can provide these things so that the traffic can be avoided and the optimized route can be followed to reach to that hospital. So this overall thing is the example of IoE. So that we need to think where we can use IoT and where we can use IoE. Almost all the things are same, but normally IoT is only the interaction among the things. There is no concept of process, data, things, people. So we can say in this concept, we can say IoT is the subset, whereas IoE is the superset. So this is the another thing of cloud IoT. So amalgamation of cloud computing and IoT features. IoT devices use scalability and everything as a service feature to grow. So this is the thing that sensors are there, mobile devices are there. We can use this thing. There are number of fog devices are there. So in the fog side, what actually they can do, instead of giving all the load to the cloud, few parts can be done locally to avoid the bottleneck problem. Because if we can depend on for every computation, if we depend on cloud environment, then some bottleneck problem may arise. So in that case, we can distribute the load. So to distribute the load, what we can do, whatever the data collected from sensors or mobile devices, that can be here. This is the fog layer. PC, personal computer, notebooks, or gateways are there, where real-time data processing can be possible and computational offloading can be possible here. So just like one example I can give here, that some rural healthcares are there, where the patient's data are collected from different kiosks. And next, what is the concept that all the data are uploaded to the cloud server, and where the data can be processed, and finally, doctor can check the result. Now, if I depend on everything on cloud, then the load will be totally for the cloud, and sometimes bottleneck problem may arise because number of rural kiosks are there. So what we can do, we can consider one middle layer where some notebooks or gateways are there who can do some local processing. Just like just suppose I want to check that how many patients are there in this village with these patients. How many are this blood pressure like this. So this type of data, if I want to collect, I can easily collect it from the local server instead of depending on the cloud. So this concept from this core level is the wearable, then it can be considered as the connected cars or smart car, smart home, smart city, and then this is the industrial internet, transportation, oil and gas, healthcare. So this lower layer of IoT actually implies the IoE. So that we need to think that when we can use the term IoT and when we can use the term IoE. And already I mentioned this part here that this layer part, fog layer, to reduce the load of the cloud, we can use middle layer, that is the fog layer. And same thing here, it is the edge computing. Sometimes also we can see this, we can consider it as the edge. Edge is the middle part, that is to avoid the data, to reduce the data. So number of IoT devices are there. So instead of uploading all the data in cloud, what we can do, we can consider one edge here, and few data are processed here, and processed data are uploaded into cloud, and their final processing can be done. So edge computing allows computing resources and application services to be distributed along the communication path via decentralized computing infrastructure. So what is edge? An edge device is any piece of hardware that controls data flow at the boundary between two networks. So from this edge concept, edge layer, we can consider two things which are very important for any real life applications: edge analytics and edge intelligence. Nowadays, analytics is very common part, and intelligence is obviously required term. So edge analytics is basically when we apply data analytics at the edge level. That is termed as edge analytics. So we can capture data, perform analysis, send process data, and in the cloud, store or process data in the cloud, and then finally perform the action. Now, edge intelligence. In that case, if we can apply artificial intelligence at the edge level, then this is termed as edge intelligence. We can capture data, perform analysis. We can store some metadata, that is optional part, perform the action, and notify the cloud. So in edge intelligence, what we can do, we can apply some intelligence level to do the action, most of the action at the edge level, to reduce the load of the cloud. And final information or decision notification can be forwarded to the cloud. So you can see from this that edge intelligence is enabling intelligence beyond cloud. Artificial intelligence applications are there: connected health, connected vehicles, smart manufacture, smart home, video analytics in public safety. And we can also see in the edge computing enablers what this IoT data, edge devices, huge storage, wireless communications, security and privacy. So these two areas have been merged with the help of edge intelligence. Another very important application in today's world is cybersecurity. So AI enables machines to learn from experience, modify techniques when fed with new datasets, and carry out tasks that are human-like. Predictive security principles of computational intelligence apply to cybersecurity. And AI helps to identify and check if files contain malware, which is carried out with the help of machine learning as well as deep learning. Machine learning generates knowledge from past experience, not simply memorize examples. picks up laws and patterns to apply where relevant. Conventional approaches fail to offer strong protection. Malware programs designed to make slight changes and breach traditional systems. Machine learning can detect unknown and modified malwares too. Machine learning keeps evolving and improving as it is used more and fed with more data. Machine learning scrutinizes file elements to comprehend nature of attacks by considering simple file size to complex codes. Benefits of employing machine learning in cybersecurity are numerous. Few drawbacks can be overcome with deep learning. Main limitations of machine learning are its inability to handle many variables at once, requirement of huge computing powers, and using up a lot of space. In deep learning, unstructured data stored in neural networks and decisions are made using predictive reasoning, modeled on working of human brain potential to manage numerous points of information without hampering speed of system. Deep learning is better as it includes mathematical models that learn over time. For this, large amount of data is used, such as trends, malicious URLs, and other modes of attacks. So healthcare is very important. Healthcare has always been one of the focal points of artificial intelligence. It boasts of a huge amount of data to populate and analyze based on which computational sophistication has been improved by designers. AI tools can predict substantial challenges lying ahead in advance and offer resources for patient education and proactive interventions, thus helping people to maintain their well-being. Other things, it offers an application capable of detecting lymph nodes in the human body in computer tomography images, CT scan. If the detection is done by humans, the charge would be prohibitively expensive. So instead of doing it manually, if we can do it through the deep learning or any other machine learning algorithm, the cost will be less. So in this scenario, deep learning trains computers on datasets to learn what an irregular appearing versus a normal looking lymph node is. Once done, radiological imaging specialists apply this knowledge to real patients and identify the extent to which somebody is at risk of carcinogenic lymph nodes at a significantly lower cost. So this is one example. Number of applications are there where we can use this type of deep learning and machine learning also. Another field is transportation. So transportation is a field where artificial intelligence together with machine learning has produced major innovations. Autonomous vehicles like cars, buses, trucks, etc. use advanced capabilities that offer features like lane changing system, automated vehicle guidance, automated braking, use of sensors and cameras for collision avoidance, and analyzing information in real time by using AI, among others. Natural occurrence. So AI is considered as one of the perfect sources of predicting natural occurrence. There's an AI model that can almost perfectly guide you what the weather will be for the next couple of days, which was almost unimaginable before the advent of artificial intelligence. There's also an incredible system that can predict based on the simulation of tectonic plates of the earth, the time of volcanic eruptions. There are AI-enabled projects that gather data for magnetometers of the phone and send it for analysis based on which successful predictions about earthquake can be made. So these are the few application areas where AI can predict the natural occurrence. Next is smart farming. Farming is another sector that has been heavily benefited from disruptive technologies. This is an industry full of challenges like competition for natural resources and rapidly growing populations. In this scenario, consider FarmLogs, a farming management app presently used by many farmers in the US, which uses technology and data to help farmers track the weather, monitor fields, obtain insights into soil, utilizing historical satellite imagery, and even identify irregular plant growth. Real-time data analytics help farmers to maximize their crop yields and thus in turn their profits too. So you can see with the disruptive technology, agriculture 4.0 is very much related. So from the concept of this disruptive technology, we can say agriculture 4.0 can appear. So initially this is only the product concept, then it becomes smart product, smart connected product, product system, then system of systems. So this is the concept of agriculture 4.0, and this is only possible with the help of disruptive technologies. So there is the facility systems, weather data system, farm management system, farm equipment system, and seed operational systems. So overall, this is the system of system, that is the feature of agriculture 4.0. So the impact of disruptive technology in agriculture 4.0 is huge. Artificial intelligence is considered as a way to deal with large volumes of data and to identify efficient ways to responding to various public requests. Smart city applications often use disruptive technologies to improve environmental planning, service delivery, energy utilization, resource management, crime prevention. Some of the top applications include intelligent traffic signals, e-governance applications, smart meters for utilities, Wi-Fi kiosks, etc. Preventing environmental resources. Disruptive technologies has potential to combat effects of climate change to improving recycling systems. AI combined with robotics can transform the recycling industry, allowing for better sorting of recyclable materials. This will reduce cost for the industry as well as improve the environment. Artificial intelligence, machine learning can manage renewable energy for maximum efficiency, forecasting energy demand in large cities, and making agricultural practice more efficient and environmentally friendly. AI is also protecting habitats and animals around the globe, and it can be used to detect and locate poachers. Now, if we can see this concept of blockchain in academics. So this is instructor enter records. This is the administrator who endorse records. This is the endorsed records, and it is inserted to blockchain network. I'm not going through the details of blockchain network, just I'm mentioning the application areas. The blockchain network, through blockchain network, this academic records becomes standardized and secure. Now, this is the graduate students' academic records. It is sealed according to this. Now, external entity like employer can send the verify request through the verification server to this blockchain network for searching and retrieving the records, and this employer can easily check the verification for this particular graduate. So this is easily possible through this blockchain concept. Beside this, blockchain can also provide clinical trial management. It reduces trial timeliness, ensure transparency and traceability of patient records, facilitate data sharing, ensure regulatory compliance, medical supply chain, trace medical equipment, improve inventory planning, streamline communication between stakeholders, user privacy protection, protect user identity, limit sharing of personal information, grant user permission to selectively share information, data aggregation, it collects data efficiently, ensure data provenance and immutability, build real-time and audit trail, contact tracing, it can track patient movements, provide real-time data about infected zones, help identify free virus zone. Donation tracking can also be possible. Transparency of donation process, reduce corruption related to donation, improve social trust among citizens. Outbreak tracking, reduce risk of information falsification, increase reliability on trusted sources, provide real-time accurate tamper-free and transparent information. So already I mentioned these application areas of blockchain technologies. Online education is also one application area, patient information sharing, supply chain management, contact tracing, automated surveillance, contactless delivery, disaster relief, and insurance. So if you can consider, this is the blockchain participating nodes, and this is documents on ledger or online or offline. So online patient record, tested result, online treatment status, discharge summary. Here in the blockchain participating nodes, who are these patient, testing labs, hospitals, governments. What are the things? Patient discharge. What are the things that you can be considered through blockchain? Patient discharge, generate discharge summary, patient tested negative, treatment status updated, treatment for COVID-19 initiated, patient admitted into facility, patient tagged for quarantine, test result for COVID-19, test lab acknowledged receipt for sample, patient record based on COVID-19. So all the things can be maintained by the blockchain. So it can be used to, blockchain can be used to monitor pandemic material distribution, donation, relief distribution, and other response in a fast and transparent way without violation of user data. Contact tracing applications can be built on blockchain to allow anonymity, bring reliability, transparency, and security to medical data. Blockchain-based global pandemic map used to track spread of virus, number of infected citizens, and number of recovered citizens. Health insurance claims can be managed through blockchain and smart contracts. Decentralized payment method plays vital role in defeating virus, as companies can receive payment through cryptocurrencies without risk of spreading virus to cash. Tokenization provides a unique opportunity to rebuild society after the COVID-19 pandemic. Blockchain can be used to promote transparency during fundraising and donation camps. So if the blockchain and AI can be merged, this is the coronavirus data. Data sources are from there: clinical labs, hospitals, social media, patient-generated data, wireless network operators provided data. These are the blockchain functions for coronavirus fighting. So outbreak tracking, user privacy protection, safe operations, medical supply chain, donation tracking. AI functions for coronavirus fighting, outbreak examination, outbreak estimation, coronavirus detection, coronavirus analytics, vaccination or drug development, prediction of future outbreak. And all these cases, security and privacy need to be maintained. And who are the stakeholders? Governments, public, researchers, healthcare providers, regulators. So in this way, we can also merge different technology, disruptive technologies as a whole. So again, this is the pharmacist and patients. All are the stakeholders connected through blockchain. So doctor, clinical decision support document can be forwarded to this. Disease diagnosis can be go to the X-ray technician. Health advice can go to patient. Valid prescription can go to pharmacist. Validated government policies and rules and regulation go to healthcare policymaker. And data collection and analytics can go to the data analyst officer. Now, if blockchain and IoT can be merged, then in that case, it can be divided into 3 levels: mesh level, digital level, and intelligent level. In the mesh level, we can see conversational system, mesh app and service architecture, digital technology platforms, and adaptive security architecture. This is the mesh level. In the digital level, we can see virtual reality and augmentation reality, digital twins, blockchain, and distributed ledgers. And in the intelligent level, artificial intelligence and advanced machine learning, intelligent apps, intelligent things. So you can see mainly intelligence things and blockchain and distributed ledgers can be combined to do work efficiently. So the benefit of using blockchain for IoT is it can accelerate transaction, reduce cost, and build trust. Now, current landscape of AI, blockchain's role in AI technology. This one is help us build a distributed supercomputer. So what AI blockchain can do here is to help you out to build a distributed supercomputer. Users on the network can lend their computing power, and by connecting them, it can become a supercomputer in no time. Solve the trust issue. So blockchain would be able to track the AI's communication with other instances. Thus, it can rebuild your trust in AI and you would be able to depend on its safety. Next is increase the overall AI user experience. This new AI blockchain technology can be used to build innovative, smarter applications and connect different marketplaces. Not only blockchain would be able to connect all the marketplaces at once, but it will also give rise to new AI business. So in this way, we can say that either we can use disruptive technology alone for societal benefits, or we can merge one or two technologies to improve the quality of work. But our ultimate objective is to provide some solutions to the society which can benefit the society, and we can also apply the advancement of the technology. Now the problem is that there is a huge variation in the economical condition of the developed country and developing countries. So the developed countries use this technology in such a way, this type of usage may not be possible in case of developing countries. And also if we consider this type of self-driving car or autonomous car, in India till now, it is not very feasible to think about self-driving car or autonomous vehicle. Price is also maybe too high for the general people, general public. So these are the few things that are the constraints for the application of the disruptive technologies. But in any case, we need to think about based on the social condition, because already I mentioned that disruptive technologies can be considered for 3 levels based on the economic condition. So one is the high income countries, then middle income countries and low income countries. So whatever the things, according to the level, we need to apply the technology and we need to use this technology in such a way so that society can get the benefit as a whole. Thank you.
Thank you, madam. Sunil,
yeah, thank you so much, ma'am, for giving a brief idea and a brief description about how pandemic is going to be what we can say commanding by artificial intelligence, and especially you make the differences between, as of now we are knowing about only IoT and how the future is going to become with the IoE, that is the Internet of Everything. And you explained with a clear example, with a practical example of the helmet, which is going to give everything, the information for the nearby hospitals and ambulance and everything. So thank you, ma'am. Thank you so much for giving natural resources what we are using and how the smart farming is going to be held, especially in India. So whatever the disruptive technologies that we are using, you gave a clear idea, ma'am. Thank you, ma'am. Thank you so much for being part of this FDP. Thank you so much.
Thank you. Thank you, sir. Thank you so much.